Welcome students to the second part of lecture number 3 of problem solving using computer. Students, in the part 1 of lecture number 3 we discussed various units of computer memory. In this part we will discuss memory hierarchy. Students, we have various types of computer memory devices. Few examples are RAM, CPU registers, hard disk, magnetic tape, CD, DVDs, etc. Students, broadly we divide these computer memories into two parts. First one is internal memory and second one is the external memory. Students, internal memory is that memory which can directly send or receive data from the CPU. The internal memory is used to store the instructions that are to be sent to the CPU, the intermediate results obtained during processing, and the final results obtained after processing. Okay. Students, the examples of internal memory or primary memory are CPU registers, cache memory, and RAM. And students, the secondary memory or the external memory is that memory which cannot directly interact with CPU. The reason of this is the slow data transfer rate of secondary memory, and to send the data to the CPU from the secondary memory, it need to be first sent to the primary memory, and from there it is sent to the CPU. Okay, the examples of the secondary memory or the external memory are hard disk, optical disk, magnetic tape, etc. Students, the memory hierarchy is a representation of various types of computer memories. Through this, we understand the order in which the data is transferred from one memory to the other memory. Through this, we understand the distance between one type of memory and a CPU. Through this, we understand the size of a particular type of memory. And through this, we also understand the cost to store the information in that memory. Okay. So the memory hierarchy gives us an abstract level understanding of various types of memories used in the computer. Students, let's now compare the various types of memories used in the computer. Firstly, we make the comparison on the basis of speed of data transfer. Students, the comparison of the various memories on the basis of the speed of data transfer is visible on your screen. You can see that the data transfer rate of the registers is fastest. Its data transfer rate is almost equal to the processing rate of the CPU. So all the instructions which are processed by the CPU are firstly sent to the CPU registers, and from there they are sent for the processing. Okay. Students, after that comes the cache memory. We know that the data storage capacity of registers is limited, so we need another memory which is fast and which can store a large amount of data than the registers. So this role is played by the cache memory. Students, the cache memory fetch those instructions from the RAM which are to be executed by the CPU in the near future. Okay, so the cache memory, it acts as a buffer between the RAM and the CPU registers. Okay. Students, after that come the RAM. Students, the data transfer rate of RAM is slower than the cache memory, and it is much slower than the registers, but it is more than the data transfer rate of the hard disk. Okay. And students, we also know that RAM is used to store the data and the instructions which are to be executed by the CPU, and the intermediate results produced during the processing of the instructions, and also the final results produced after processing. Okay. Students, after that comes the hard disk. The data transfer rate of the secondary storage devices such as hard disk, optical disk, and magnetic tape is quite slower, and that's why we cannot send the data directly from these devices to CPU, and we send the data from the secondary storage devices to the RAM. And in these devices, the data transfer rate of the hard disk is more than the data transfer rate of optical disk, and the data transfer rate of optical disks is more than the data transfer rate of the magnetic tapes. Okay. Students, let's now compare the various memories on the basis of their storage capacity. The lowest storage capacity among these memory units is that of registers. It can have a storage capacity of 8 bits or 16 bits, and the storage capacity of the cache memory is more than the storage capacity of registers. Its storage capacity vary between 1 MB to 16 MB in these days, and after that come RAM, or the random access memory. Its storage capacity is much higher than the storage capacity of the cache memory. In these days, the capacity of the RAM in most computers is between 4 GB to 8 GB. Students, after that come the secondary memories. Here the storage capacity of optical disks, it range from 700 MB to 8.5 GB these days, and after that comes the hard disk. In most of the computers, the storage capacity of hard disk is 500 GB to 1 TB, and after that comes the magnetic tape. The storage capacity of the magnetic tapes is highest, and that's why it is mostly used for the backup purpose. It is used for the archiving of the data. Okay. Students, let's now compare which of the following memories are volatile in nature and which of them are non-volatile. Students, the primary memories such as the register, the cache memory and RAM are volatile in nature. It means the data stored in these memories gets erased when we switch off the computer. Okay. Students, the secondary memories such as hard disks, optical disk and magnetic tape and other secondary storage devices are non-volatile in nature, and they can store your data even after switching off the computer, and that's why these are used for the permanent storage of data. Okay. Students, let's now compare these memories on the basis of the price to store 1 bit of information in them. Students, the price per bit for register is highest, and after that it comes for the cache memory, and after that comes the RAM, and after that comes the hard disk, and after that comes the optical disk, and the cheapest memory is the magnetic tape. Okay. Students, let's now understand the memory hierarchy diagram or the memory hierarchy design. Students, as you can see that in this diagram, the various types of memories are shown as the component of the pyramid. At the top, we have CPU registers, and after that we have the cache memory, and after that we have main memory, and after that we have magnetic disk, and after that we have optical disk, and at the bottom we have the magnetic tape. Students, from this diagram we can understand the distance of various types of memories from CPU. This diagram shows that the distance of the CPU register is least from the CPU, and after that comes the cache memory, and it increases in the downward direction. So the distance of the magnetic tape and the CPU is the highest. Students, this diagram also show the storage capacity of the various memories in the computer. It shows that the CPU register's storage capacity is least, and after that comes the storage capacity of the cache memory, and after that comes the storage capacity of the main memory, and it shows that the storage capacity of the magnetic tape is the highest among all the various types of memories. Okay. Students, from this diagram we also understand the access time of various types of memories. From this we understand that the access time of the CPU registers, or the data transfer rate of the CPU register, is the lowest, and the data transfer rate or the access time of the magnetic tape is the highest. Okay. Students, from this diagram we also understand the cost per bit to store the information in various types of memories. Students, it is clear from the diagram that the cost per bit increases as we move from bottom to up. It means that the cost per bit for the magnetic tape is the lowest, and after that it comes the optical disk, and the cost per bit for the CPU registers is the highest among all the types of memories. Okay. Students, I think you got the abstract idea about the various types of memories used in the computer, and I think you have understood what is the basic need of the various types of memories. Okay, so this is the end of lecture number 3 of problem solving using computer. Thank you for attending this lecture. See you in the next lecture.